Have you ever actually stopped to think about where our massive, just unimaginable amounts of digital data live? I mean, every photo you back up, every movie you stream, every single complex algorithm running your favorite apps, where does it all physically go? Well, welcome to This Explainer. Today, we're setting out to solve the core mystery of the modern internet. We're going on a bit of a journey today, tracking the fascinating evolution of cloud computing. We'll explore how this concept started out as just a metaphor for this amorphous, invisible network, and how it's rapidly evolving into a highly intelligent, decentralized central nervous system that powers, well, almost everything we do.
So here's our roadmap for today's explainer. We'll be covering 1. Decoding the cloud. 2. The three service models. 3. Edge versus cloud computing. 4. The AI and cloud synergy. And finally, 5. Navigating cloud challenges.
Okay, let's dive right in. Section 1. Decoding the cloud, from mainframes to hyperscalers.
To really grasp what the cloud is today, we have to look at how we got here. And the foundational idea, it actually isn't all that new. Back in the 1960s, users were already doing a form of time-sharing through remote job entry on these massive room-sized mainframes. But the actual cloud metaphor, that dates back to 1994. It was coined by a communication specialist at a company called General Magic to describe this whole universe of places that mobile agents could go. By 1996, Compaq was drafting business plans predicting that online consumer file storage was going to be a massive commercial success, and they hit the nail on the head. Then a huge leap happened in 2002 when Amazon Web Services, or AWS, was established, which finally allowed developers to build applications independently. And that brings us to the modern era, which is absolutely dominated by massive hyperscalers like AWS, Microsoft Azure, and Google Cloud, providing infrastructure on a scale that was previously unthinkable.
And when I say unimaginable scale, I literally mean trillions. $1.3 trillion to be exact. According to projections by the International Data Corporation, global spending on cloud computing services is expected to hit that staggering mark by 2025. We're talking about an absolute foundational pillar of the global economy here.
But what exactly makes a system a cloud, right? It can't just be any random server hooked up to the internet. The National Institute of Standards and Technology actually grounds this abstract concept in 5 really concrete pillars. First up is on-demand self-service, meaning you get resources automatically without needing human intervention. Second is broad network access, so you can reach it from any device. Third is resource pooling. This means providers are serving multiple different customers from the exact same physical hardware. Fourth is rapid elasticity, so the system scales up and down instantly based on what you need. And finally, measured service, which just means you only pay for exactly what you use. It's essentially just like your monthly water bill.
Moving right along to Section 2, the three service models. That's IaaS, PaaS, and SaaS.
Let's completely dissect the current DNA of the cloud. I want you to think of these models like a giant stack of building blocks, where each block trades a certain level of control for convenience. Down at the foundational step, we have IaaS, or Infrastructure as a Service. This is where you're basically renting the raw digital real estate, virtual machines, storage, networks. You have total control here, but also the most responsibility to maintain it. Move up to step 2, and we have PaaS, Platform as a Service. This gives developers a ready-made playground to build and deploy applications, so they don't have to worry about managing the underlying servers at all. And finally, sitting at the top in step 3, we have SaaS, Software as a Service. This is the finished product hosted in the cloud. Think Google Workspace or Netflix, the stuff you and I probably use every single day.
Now, what's really fascinating here is when we compare these models directly using an ANOVA statistical analysis, clear trade-offs start to jump out. IaaS is the absolute winner for scalability and security. It offers unparalleled flexibility and control over your resources, which makes it perfect for massive enterprise scaling. But PaaS actually takes the crown for cost-effectiveness. By stripping away the burden of managing the physical hardware, it drastically cuts down operational costs for software developers. The big takeaway here? There is definitely no one-size-fits-all solution. The block you choose directly dictates your budget and your security posture.
Okay, let's switch gears a bit. Section 3, Edge versus cloud computing. Are they complementary or competitive? So the centralized cloud is incredible, but it has one inherent flaw, a latency problem. Put simply, distance creates lag. Cloud computing gives you virtually unlimited scale and raw computational power, but because that data has to travel back and forth over the internet to a centralized server, you are always going to deal with higher latency. Edge computing, on the other hand, is a distributed model designed to fix exactly that. It brings the computation right to the physical location where the data is actually being generated, like a local sensor or an edge server. You have a much more limited scale, sure, but you achieve ultra-low latency and real-time processing. So are these two paradigms fiercely competing? Not exactly. They actually work together beautifully in a complementary hybrid model for real-world applications. Take autonomous vehicles, for instance. The edge plays the absolutely crucial role of making split-second local decisions, like slamming on the brakes for a pedestrian, because you simply cannot afford a round-trip cloud lag in that scenario. But the cloud? The cloud handles the heavy lifting, like long-term route optimization and analyzing fleet-wide data. Or look at healthcare. The edge monitors a patient's vitals in real time right there at the bedside, while the cloud securely stores decades of health records and runs incredibly heavy AI diagnostic models. They perfectly compensate for each other's weaknesses.
Let's see how this all builds together in Section 4, the AI and Cloud Synergy, the Intelligent Evolution.
As global data volumes completely explode, human administrators literally cannot manage the cloud alone anymore. AI is stepping in right now to act as the autonomous brain of this entire infrastructure. To really anchor this, just look at the synergy happening at major brands today. Netflix uses AI within its cloud infrastructure for predictive content delivery. It literally analyzes your behavior to preemptively allocate server space for the exact shows it knows you're about to binge, ensuring you never see a buffering screen. Microsoft Azure Sentinel uses AI for real-time threat monitoring, constantly scanning massive global databases to spot and neutralize security threats before they even escalate. And Google Cloud Operations uses AI for automated infrastructure management, dynamically detecting anomalies and fixing its own misconfigurations without a human ever lifting a finger. It's essentially self-driving, self-correcting infrastructure.
But it's not all perfectly smooth sailing. Let's look at Section 5, Navigating Cloud Challenges, and the hurdles in this ecosystem.
Remember, this massive infrastructure is still built by humans, and it faces some really intense structural hurdles. First up, cost overruns. The pay-as-you-go model sounds absolutely fantastic on paper, but a recent Gartner report revealed that an astonishing 69% of IT leaders experience budget overruns. Without rigorous, constant optimization, unused cloud resources become these hidden financial drains. Second is security and privacy. The cloud operates on what's called a shared responsibility model. The provider secures the physical hardware in the building, but the customer, you, must secure your own data and access identities. Misconfigurations on the user side lead to massive breaches. And third, there's the incredibly complex legal tension of extraterritorial data access. For example, the U.S. Cloud Act allows authorities to request data from American cloud providers, which sits in direct legal friction with Europe's very strict GDPR privacy laws. Cloud providers are basically caught right in the middle of a massive global tug-of-war.
So the crucial point here really boils down to this concept of leaky abstractions. We love to think of the cloud as an infinite, magical, perfect resource just floating up in the sky, but it's not. It is built on very real physical hardware, real-world fiber optic cables, and human-coded software. When things go wrong, say a server catches fire, a network connection drops, or a legal boundary gets crossed, the abstraction leaks. And suddenly, users are forced to confront the highly complex, messy physical reality of where their data actually lives.
Which leaves us looking ahead to the very next frontier. We've gone from mainframes to centralized hyperscalers, and now we're pushing intelligence out to the absolute edges of the network. So the big question is, will the cloud of the future even be centralized at all? Or is it going to become a fully decentralized, highly intelligent web living in the billions of devices all around us? It's a fascinating question, and for sure one that will define the next decade of technology. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.